So in this video, we're going to look at 4 examples where we're going to be solving the equation for x. And in each of these equations, we're going to apply some sort of inverse function property. Now remember, because a trig function has an inverse, we went through that whole process to make our trig functions have inverses. We forced them into this position. We then get to use the properties of functions and their inverses to apply and use those properties to solve equations. So here I have y is equal to 5 cosine x, and I'm trying to get x by itself here. So the first thing I want to do is divide off this 5. I need to get the trig term by itself. So this becomes y over 5 equals cosine x. So x is inside of the trig function, let's say. It's the angle position here, and it's in the trig, in the angle position. In order to get it out and to get it by itself, I need to take the inverse cosine of both sides. Now what that does, when I take a function and compose it with its inverse, I get back this x. So a function with its inverse composed together gives me back this value right here. And the way that I write that looks like x is equal to the inverse cosine of y over 5. All I did was change sides here because I like my x's to be on the left. So this is the answer that we were looking for. I solved the equation for x. I didn't get anything pretty here, no real succinct answer, but I did get to rearrange the equation solving for x. Now let's look at another example. This one says y is equal to 3 cosine 2x. Again, I'm trying to get x by itself, which is here inside of this angle position again. So this is a similar concept. I want to divide both sides by this coefficient of 3, and I end up with the cosine of 2x equals y divided by 3. So again, I like my terms over here on the left-hand side, so all I did was rewrite it in this manner. Now, I can use the inverse cosine property or the inverse property here. Take the inverse cosine of both sides because cosine and cosine inverse composed with each other gives me 2x. So I end up with 2x is equal to the inverse cosine of y divided by 3. Now I'm not done yet because I still need x by itself. So I'm going to divide both sides by 2, just like I would normally if I was solving an algebra problem. And that leaves me with x equals, now I'm going to pull this 2 out front so it looks like 1/2 cosine inverse of y over 3, just so that it's a little bit cleaner looking. Okay, so each time, what are we doing? We're taking, in this particular case, since I'm solving for cosine, I take its inverse and it returns the angle. Let's look at another example here. 3 arctan x equals pi. So I am solving for the variable x. Now I know what pi is. Pi is a numerical value that's represented by 3.14, approximated by that. So I can actually solve and get an answer in this particular case. So I'm going to rewrite this so that it looks like 3 inverse tan x equals pi. I just like to see mine written as an inverse tan as opposed to arctan. Since I'm trying to get the trig part by itself, I'm going to divide both sides by 3. I have tan inverse x is now equal to pi over 3. And to get x by itself, I would take this time tan of both sides. Right? And tangent composed with inverse tangent leaves me just the variable x. And now I have to ask myself, okay, well, the tangent of pi over 3 is just square root of 3. So I actually could solve this particular equation and get a real value. All right, the last one we want to look at together is this right here. Y is equal to the cosine of x plus 3. Again, I'm trying to get this portion by itself. I do that by taking, you guessed it, the inverse cosine of both sides, and I end up with the angle that's right here, x plus 3, is now equal to the inverse cosine of y. but I'm going to subtract 3 to the other side to get x by itself, so I have the inverse cosine of y minus 3. That's really almost just rearranging the equation, but I did do what it was asked, and I did solve this equation for the variable x.